Well, we used the law of sines to when we knew angle side, and now we're going to use and apply the law of sines when we know angle side angle. So we have this little problem here where two ships are 250 feet apart and traveling to the same port as shown. Find the distance from the port of each ship. Well, let's see what we know here. All right, so here's the port, and there's an angle that exists because we have a triangle here. And if I look at this, the angle from the ship to the port, or the angle here of ship A, maybe I should say, is 39. So there's an angle. We know a side here because these ships are 250 feet apart. And the angle here of ship B is 41. So we've got angle, side, angle. And we're trying to find the distance of each ship. When we know the side opposite the angle here at the port going to each ship, but I need to find that angle first. Well, of course, that's easy enough to do. We can just say that we got 180 minus 39 minus 41, and that's going to give us the angle, let's call that just angle P, port, okay? How about that? So I got 180 minus 39 minus 41, so that's 100. So this angle then is 100. And I know the side opposite it, 250. Well, I need to find side A opposite where ship A is and side B opposite where ship B is. And let's use the law of sines to do that. So we can say then that the sine of angle P, which is 100, we just found, over side P, which is 250, equals, I don't know that it matters. I think I'm going to go with side B first. So the sine of 41 over side B. And again, we're just going to cross multiply. So we got B equals the sine of 100. That's going to equal B times the sine of 100 is equal to 250 times the sine of 41. And B is then going to approximately equal 250 sine 41 divided by sine 100. And this is measured in feet. So let's go through this calculation. This is going to give us, actually going to give us the distance from ship A to the port. Okay. Even though we're using the angle of ship B to find that. So I got 250 times the sine of 41, and that's going to be divided by the sine of 100, and that gives us 166.5 166.5 feet. So that's this measure right here, which gives us the distance from ship A to the port. Don't get confused on how that actually shaking out. Now let's find side A, which is going to give us the distance from ship B to the port. So again, we've got the, I'm going to go up here and do this. This is the sine of 100 over 250 equals the sine of 39 over A, which happens to side A, which happens to be the distance from ship B to the port. And again, after we cross multiply, and if you don't mind, I'm going to shortcut this a little bit, where A is going to equal 250 times the sine of 39 divided by the sine of 100. Look at that, make sure you follow me on that. So A is going to approximately equal 250 times the sine of 39 divided by the sine of 100. And that comes to approximately 159.8 feet. So side A over here is going to be approximately equal to 159.8, which gives us the distance from ship B to the port. And I suppose if they're traveling at the same speed, at a constant rate of speed, ship B is going to get there first, right? It's got a shorter distance to go. Wonder if they're going to have to hold one of the ships off, because I don't know how many ships can dock at this port at the same time, which might present another interesting dilemma. But hey, at least now we know about how far away each ship is from the port by using the law of sines.